All right, are you ready to start your quiz review?
Yes,
We are going over section 2, topics 1, 2, 3, and 4. So this is when we started solving equations. All right, the very first one, it says to check all that apply, and it's very important that you show your work for these problems. Okay, which of the following equations have the correct solution? Select all that apply. So this goes back to our, I think, topic 1 with like the true false statements. Okay, so we're going to check off the boxes if they're true. So they give me an equation, they give me a value for x. If I plug it in, do I get a true statement? All right, is what it wants me to do. So the very first one says 2x plus 9 equals 15. They claim when x equals 2. Right? Tyler, you're saying not true. How come?
Because if you times 2, it's 4 plus 9, that's 13.
Good. So you actually plugged in the 2 for x. So he said 2 times 2 gives you 4, and then 4 plus 9 is 13. That is not 15, right? That is not the same thing. Therefore, that is not a true statement. But I showed my work, right, Gabe? I showed my work. So you should be showing your work. Whether or not you check off the box, you're showing your work as to why you are or you are not going to check the box. All right, my next one, 5 equals 3x minus 1 when x equals 2. You think it's true this time? Let's see. 5 equals 3, 2 minus 1. All right, well, what's my first step in? Okay, I did that. I plugged it in. Then what? 3 times 2 gives me 6 minus 1. Is that true? Does 5 equal 5? Yes. Woohoo. So I am going to check off that second one. All right. It's a quiz. 3x minus 5 minus x equals 15 when x equals 15. All right, so I'm going to first write it through, and whenever I see an x, I'm going to stop and put 15 in its spot. So this was an x, and this was an x. Yes, ma'am. Yes?
So then you distribute the 3 to the 15 and 5.
Well, you don't have to. You could, but what could you do before that? Not divide.
Oh, you can get rid of the 15.
Not that. Think of order of operations. What's the very first letter? Parentheses. I can do the parentheses first this time. So you wouldn't be wrong if you distributed. You would have bigger numbers. But to keep my numbers smaller, we are going to combine like terms first. So let's do that first. Now tell me what to do.
Then you could just times 3. No, 3.
Yeah, you're right. 3 times 10.
30.
Okay.
And then you just get rid of the 5 by adding 15 to both sides.
Well, we're not solving for x. I don't have to move stuff over. I just have to actually simplify. So what is 30 minus 15? So I get 15 equals 15. So all of these, I've replaced x with the number, so I don't have to move stuff to the other side. Does 15 equal 15? Yup. Am I going to check the box? Yes, I am. I know, right? All right, x minus 2. Okay.
So you can plug in a 9 off the rip. So 9 minus 2. Right? And then after that, you're going to be 7, obviously. And then you say 7 divided by 7. Right? And of course, it's going to equal to 1. So you're going to do 1. That's the answer right there. But of course, that's not close. And then you say
Very good. It is not going to be true. Beautiful. When you plug in 7, or we're plugging in 9, excuse me. That symbol right here, that slash, represents division, which Jehovah recognized. So 9 minus 2 is 7. 7 divided by 7 gives me 1, and 1 does not equal 4. So, am I going to check the box? Nope. One more. Yes, there's a fraction, but that's okay, because fractions are just what? They're just division. Good. Fractions are just division. What am I going to replace x with this time? Good. There we go. So to multiply by 1/5 is the same thing as dividing by what is in the bottom? A 5. So multiplying by 1/5 is the same thing as dividing by 5. Multiply by 1, divide by 5 is what that fraction shows me. So I can put 15 over 5 like that. That's the same thing. What is 15 divided by 5? It is 3. Good. Good. 3 plus 3 equals 6, which is not 17. So am I going to check off the box? No. Again, I showed work for each example. There were, 5 choices? I showed work 5 times. Okay? You got to do that on your quiz today. Make sure you show me why or why not check off the boxes. Questions about this? Go with number 1. All right, let's go on to number 2. Sorry it's so small. On your quiz, the printing is a little bit better. So I apologize for having you squint your eyeballs. So here we have an equation. It has already been solved for me. The math has been done. We are going to write next to it what operation or property was used each step. Okay, so the very, very first one we know is always given, and it is written there for me very nicely. Sierra. Good. The very first thing they did was they did distribute that 2 to 1/4 and -3. What operation is distributing technically? Multiplication. Yep. Good. To distribute means to multiply. The reason why we don't say multiplication, because we didn't do it to both sides. We only did it to one side. No, you're good. Distribution would work just fine for me. Yep. I'm not going to be that picky. Not today. Not today. How about the next one? So I had 5 plus 1/2 x minus 6 equals 7. Now it's 1/2 x plus 5 minus 6 equals 7. Gabe. Commutative property. Good. Why do you say that? Yes, they moved the order around. 5 plus 1/2 x became 1/2 x plus 5. Good. They switched the order. Order got changed. What if grouping got changed? Meaning like something in parentheses got moved around. What's that called? Nope, this one's commutative. What if the grouping gets changed around? The associative. Yep, the associative one. Good. Which didn't happen here. All right, then they combine like terms, which is the equivalent equation, or you can put CLT if you want to combine like terms. So they actually did the 5 minus 6 to get the -1. All right, from D to E. Yes, good, Jacob. We are adding 1 on each time. So technically it's the addition property of equality, right? That nice long thing. I'm just going to put addition. Keep it simple. From E to F, they actually did the adding. So -1 plus 1 is 0. That's why it's not there anymore. Other side, 7 plus 1 gives me 8. So here they combine like terms. I've already told you it's equivalent. You don't have to write anything there. It's already filled in. I'm just showing you why it's called equivalent, because we combine like terms. And then our last one, what is it? Good, multiplication. Because to have a 1/2, right, to have a fraction of 1 over 2 is dividing. So to undo that, we're going to multiply. So this is multiplication. There we go. Good. How was that one? You like that one where the table's filled out for you? Good. You know we're going to have to do one ourselves. You know it. Questions, comments, concerns? All right, 2 down, 2 to go. It cost $27 to get into the fair with unlimited rides. It costs an additional $3 per game to play a carnival game. If you spend a total of $45, how many games did you play? Justify your answer by using an algebraic equation to solve this problem step by step. Okay, ready? Let's start with my variable, okay? So we need a variable. So what don't we know? Good, we don't know how many games. So x is going to equal number of games played. Okay, your variable is always going to be pretty much what you're answering the question. How many games did you play? Well, that's what I don't know. So x is how many games I played. D is a little wonky. There we go. Hold on. Okay, so I need to write an equation. Okay, 27. That's important. $27 is to what? Is to get in. To get in the fair. How else are we spending money? The games. How much is it per game? There's $3 per game. All right, what other information do I know? Good, we have a total of $45. Okay, so those are the pieces we're going to use to write my equation. So how do you want to start off your equation, Jehovah? 27, all right. Sure, if you want to. Almost. I agree with almost everything you said.
27 plus 3.
There we go. Good. So $27 plus $3 per game equals the $45 I have. Okay. So then we can solve for x to figure out how many games I can play. Dave. Good, I like that. So the very first thing we do is subtract 27 on both sides. That gets rid of it over here because 27 minus 27 is 0. That's why I do it. We're moving it. 45 minus 27 does give me 18. Then what? Almost there. Savon. Divide by what? Divide both sides by 3. Good. And we get x equals 6. I'm not done though. I haven't answered the question. Good. How many games did you play? Played 6 games. You can be real simple and just say 6 games. You can get real fancy and say, I played 6 games with my $45 or whatever. Okay. Or you can quick to the point 6 games. So just don't tell me 6, because I don't know what you're talking about. Dogs, games, chairs, I don't know. Okay. Watermelons. Like someone always has like an abundant amount of watermelons, right? And word problems. It always happens. Yeah? Question. What if it was like 6.3 games?
We have to round it down.
Good. We'd have to round it down. What if it was 6.9 games?
We're gonna round it down.
We still round down. Good, because we would not have it. We would go over the amount of money that we have if we round up. Okay. Yeah. Of course it is. Reviews are always grades. Hopefully this is a nice, solid 100 going around. I like giving away 100s as long as you earn them. All right, last bit. Which of the following have the solution set of -2 and 2/3? What does solution set mean?
That's like,
It's what equals my x. Yes. So we're going to get x equals -2, x equals 2/3. That's what a solution set is. It's just my solutions written out. Yes, ma'am. You want to do the first one? All right. Help me work it out.
2x, 2 plus x will give you -2.
Okay.
Switch it to a negative.
All right. So you're setting your factor equal to 0,
And then
and you subtracted.
2x, you divide that will give you 2/3,
Well, hold on. What do you do before you divide on that one, though? What do you have to do first? You can't go straight to dividing. There's something else you have to do first. Nope. Nope. Subtract. Move this loose piece over because that 3 isn't being multiplied by 2, right? Just the x is. So I can't divide by 2 until 2x is by itself. So once I subtract 3. Now what do I do, Sierra?
You divide 2 on both sides.
There you go. And I get x equals negative 3 over 2. So here we got negative 2 and negative 3 over 2. Is that what I wanted?
No.
Nope. Am I going to check the box?
No.
Nope. Okay. Now what is nice about this, some of these are repeating. Like right here, x plus 2 repeats again. So I already know what that solution is. A little less work that I have to show, right? Because I already have technically shown the work for that factor. But 3x minus 2, that one's new. So let's put that equal to 0. What's my first step? Yep, plus 2. Add 2 on both sides. Am I too close to you, Sierra? Okay. This gives me 3x equals 2. Yeah, good, Alex. Divide by 3 on both sides. We get x is equal to 2/3. Is that what I want?
Yeah.
Yes. Let's check off that box. Woohoo! I feel like y'all are in a good place. You're giving me good vibes. I like it. All right, my next one. Hey, look at that. I don't have to show work, do I? Well, I already did. I already know that this one's 2/3. I just did that one before. Yeah, I just gotta show work for 2x plus 4. So what am I gonna do first? Subtract 4. Good. That gives me 2x. Oh, what is that? Let's try that again. 2x, there we go, equals negative 4. Now what? Divide by 2. I already moved before. Yeah, I already moved it before, so now to get rid of what's attached to my x, which is the 2, I'm going to divide by it. Which is going to be, well, what's negative 4 divided by 2? Which is negative 2. Is that what I want? 2/3 and negative 2? I think that's okay. That doesn't matter. My solution, I still get x equals 2/3 and x equals negative 2, right? Those are still my two same answers. So we're good. That one does work. Last one. X minus 2. I have not done that one yet. So x minus 2 equals 0. What do we do? We're going to add 2 to both sides. So x equals positive 2. Do I have to even continue with this problem, by the way? No, I already know it's not going to work for me because I need a negative 2. I got a positive 2. So I don't have to do any more work. I can stop and I know I don't have to check it off. Okay? That's still showing my work. I'm still proving why I'm not checking off the box. All right? Feel good about it? Any questions at all? No? All right. Ready for this quiz? Yes. We can do it. We can do it. Y'all want to tell my online people good luck?
Good luck, Jits. All right.